Today, our topic is Ask Me Anything. Dr. Daniel Moore from Vanderbilt and his long road of T1D care and discovery. You'll see Daniel Moore, but I wanted to introduce just a couple more people really quickly. You'll see Casey Davis. She's one of our panelists right now. She is our Director of Development at DRC, and she's going to close us today. So I just wanted to introduce her in the beginning. And then our incredible president, Dr. Alberto Hayek, where we get all of our scientific greatness from, is him. So he's joining us right now as well. And Dr. Hayek is actually going to formally introduce Dr. Daniel Moore.
So since the topic is Ask Me Anything, everybody would love to know the answer to the first question. Who is going to win the election in November? Just kidding. Okay. We don't know the answer. Okay. Well, Dan, it's a real pleasure to have you, and thank you for giving us a little bit of your time. So we share a lot of things, except age. I think I probably doubled your age by now. But anyway, we are both pediatric endocrinologists. We are both physicians that put most of the scientific and professional life in diabetes. So my question is, besides the fact that you do have type 1 diabetes, what really led you into becoming a researcher besides taking care of kids with diabetes?
Yeah, so that's a good question. I'll be happy to sort of talk about my life with diabetes and without, but why do I, besides having diabetes? So growing up with diabetes, my pediatric endocrinologist was really an advocate all the time to learn about diabetes and learn about biochemistry at the time in the 80s. And I was pretty good at sciences. I was a pretty nerdy kid in school. And so he really pushed me to go try that.
Was that at Vanderbilt?
What's that?
Was that at Vanderbilt?
No, that was in Memphis. So my endocrinologist, George Bergen, who you may know, has been around a long time, and he's like, go study that. And so I took him up on that, and I enrolled in I went to Harvard as an undergrad, and I started taking biochem classes, and I really loved them. I really loved how they explained how the natural world worked. They also included things like, how sugar is broken down and used, so things that are very important to me as a person with diabetes. But I just really enjoy how do molecules work together to produce the result that is the human body. And as I learned more about that, it was clear that diabetes was an immunologic disease. And so I started working in an immunology lab in college, and that really clicked for me. It really made sense to me, how the immune system might work and what some of the problems were. And so then as I got to the end of college, they're like, well, you could do a medical degree and take care of kids with diabetes. And that sounded really appealing. And you could do a research degree, get a Ph.D. and do immunology. That sounded really good too. Or you could do both, right? And so that hadn't really occurred to me before until sort of I was midway or later in college, but that was wow, that's kind of really what I want to do, is to both do research and take care of the children on sort of a weekly basis and put them together to deliver research to the family. So I enrolled in what's called the M.D. Ph.D. program at Penn, and I did research in immunology. I have a Ph.D. in immunology from the lab work there, and I got a medical degree. Then I came to Vanderbilt, did a residency in pediatrics so I could take care of kids, and I did a fellowship in pediatric endocrinology so I could take care of kids with diabetes. And it just all really sort of made sense to me, and just was really questions and problems that I hope that I would be interested in even if I didn't have diabetes, but certainly I was drawn to them because those are the questions that I think about every day.
So we have experience in the last, I guess, maybe 15 years or so, an explosive amount of new information, both in technology and in the biological and pathological aspects that we know about type 1 diabetes. Do you think that the technology and the advances that we have done with cells and stem cells are equal? Or do you think that one is more advanced? And which one do you think is going to be the dominant force in treating the diabetes for the next few years?
Yeah, I guess maybe I'll even back that question up a little bit. Right? So I was diagnosed with type 1 diabetes in 1976. So I have 44-ish years of experience. I'm you know, you can probably calculate my age from that if you do, but you know, so you get kind of one really impactful advance a decade, sort of in my opinion, right? So in the 1970s, like we were drawing our insulin out of, you know, bottles that were animal insulin. So you got your pork insulin or your beef insulin, and it was either cloudy or clear insulin, and that was sort of it. You peed on a stick to figure out what your sugars were, right? In the 1980s, you got human insulin. So that was one of the big sort of medical and genetic advances in the 1980s. You could make insulin that was identical to human insulin. You just really got some more blood sugar monitoring. It wasn't great yet. The meters were still pretty big and took a long time, but you could measure blood sugar on colored strips. In the 90s, you got insulin analogs. That's when I went to college and medical school. And you got Lantus and Novalogs. You got faster insulins and slower insulins. And that really changed living with diabetes, right? So by having more control over when the insulin arrived in your body, you could make new choices and new changes in your exercise and diet plans. That really changed your life. In the 2000s, we started getting more pump technology and sort of more research. In the 2010s, we got these algorithms, right? So that's really what we've gotten this decade. We've gotten a lot of discovery in terms of cells and immunology and stem cells. But as far as practical living with diabetes, I think what we're going to see mostly over the next several years, like 5 or so years, is improvement in algorithms, improvement in insulin delivery, and practical improvements in our life with diabetes. We've discovered a lot about stem cells, like say the ViaCyte project, trying to put stem cells into people to make insulin for them, but those haven't been as impactful as hooking yourself up to a robot that gives you the amount of insulin that you need in a semi-timely fashion. Those can still be improved, right? Insulin could be faster, that would be better. Insulin could act in the right location. So when you inject insulin, it acts on your muscle instead of your liver, but your pancreas actually is the friend of your liver. It lives right next door to your liver. So insulin is supposed to go from your pancreas to your liver, but when we inject it or have it pumped into us, it doesn't. So that's a problem for us living with diabetes. But these are problems that are now important to us now that we can deliver insulin better. They become more front-running problems, and hopefully we'll begin to make impact on those, and that will further improve insulin delivery. And I think that's what we'll see over the next 5 to 10 years, leading the way as compared to cells and cell therapies that still have sort of immune barriers to their application. But who knows? That's what the research is for, right? Is to get out there and find
Yeah. I think, Christina, I let you take over, and later on I will have some questions with the immunology and beta cells and stuff like that.
Okay, great. Dan, thank you so much for sharing a bit about your journey. As you know, we did have questions that were submitted to us ahead of time, so I have a few I'd like to ask you now. But I also wanted to mention to all of those attending, if you'd like to use the chat feature to ask a question, it can be a question at any time. So maybe something Dan has said today, maybe you want to ask a follow-up question, feel free to use the chat feature, and we have allocated time to get to that shortly. But let's start with our first question, which I think is one we get asked often. What is your advice for a teenager living with T1D or a parent of a teenager that has T1D? And it was sort of open-ended and a very broad question.
Yeah, this is a really hard question. I think one of the questions actually was, how do I get my T1D teen to take T1D more seriously? A lot of times there's a little bit of frustration that tinges that question, you know, coming from parents that have been working to manage T1D often for a long time. Like, you know, I was diagnosed when I was 2, so my parents had 10, 15 years of experience by the time I was a teenager handling those things. So certainly they'd be very frustrated if you don't do the things. So I think one of the things I want to step back and say, first, when we think about that question and worry about it, is that your teen probably is taking their diabetes seriously, right? They probably are, but they're not taking it seriously in the way that you might hope that they would be. And as a teen, you know, it's a real big challenge to learn what in this world is a serious thing and what is not. And they begin to learn not only from you, but also from their peer groups and from other outside sources. And their impression of what is serious or urgent kind of changes over time. And so they have a lot more competing interests for their attention than they did the few years before. And so it's easy for them sometimes to put the diabetes aside for a few minutes. Then they put the diabetes aside for a few hours. They put the diabetes aside for a few days, not because it's not important to them, but because something else has captured their attention. It is true too that about 10 to 30% of people with type 1 diabetes are living with a mental health challenge as well, depression and anxiety, and these things often do appear in teenagers, in part because diabetes is really challenging, right? You're being assessed 4, 6, you're wearing a continuous blood glucose monitor, you're being assessed like 1,000 times a day in terms of your performance, like how well are you doing, which is really kind of grating on people to get a constant progress report, especially if they're not doing as well as they would like or as well as they know that you would like for them to do. And so a lot of times I would encourage parents to step back and think about their own sort of choices. Like, you know, you might have thought, oh, I'd like to lose like 5 pounds. And you know, like that you'd be healthier if you did that. And if you had a more exercise program, you might have a less chance of getting heart disease in the future sometime. It's probably not going to help you tomorrow, right? But it would help you over the long term. But it's probably really hard for you to exercise every single day. You probably miss some days. It'd probably be really hard for you to exercise 4, 5, or 6 times a day every day. Even if it's only for like 5 minutes at a time, that'd be really hard for you. And that's sort of what we have as the expectation for our kids with diabetes is they're going to do something 4, 5, 6 times a day diligently every day without missing. And it's really important to us that they do that, right? Because if they miss, they could have a catastrophic outcome. But their experience is that they do miss and they don't have a catastrophic outcome. So when we tell them that like something bad might happen to them, they don't take their insulin, then they've already missed it and already something bad didn't happen to them. Just like you missed your workout and ate a donut and nothing bad happened to you either. And so we have to have some sympathy for sort of their experience with it, while at the same time helping them build a plan. So generally what I try to get us to do as a family is think about it as a process that we're not really worried about the outcomes. We're not really worried about the results. What we're worried about is building a plan that will allow us to accomplish the things we need to do each day. And so we need to check blood sugars, we need to give insulin, bolus for things, we know the counts of things. So how can we build a process that even if we make some small mistakes along the way, we're trying to do better about the process each day. Just like if we're trying to learn to play the violin, we're trying to improve each day by following the process, or if we're trying to run a marathon, we're trying to make some improvements on our time and plan each day. But if it's not a perfect day, that we're still safe and we're still making some progress towards our goal. And hopefully if you think about it in those sort of terms, and you think about it and reflect on your own struggles with accomplishing things over the really long term, it'll help you connect a little bit to the challenges in addition to sort of appreciating those frustrations. Because it is really hard. It's really hard when you're scared and your team hasn't taken their insulin and they might go into DKA, maybe they've had DKA before. And you really don't want that to happen again because you don't know what's going to happen to them. And it is hard sometimes for them to keep sight on that, particularly when they have other competing interests that they also know are important, like getting into college or doing well on their SAT or something else they're worried about right this minute as opposed to their blood sugar.
Great, thank you so much. So the next question is, what are the challenges with insulin today and why is it so difficult to remain stable?
Yeah, so, some people do better than others, right? I think some people have lucky diabetes, for sure. We see that. Some people have a really long honeymoon, and that's something that immunotherapy thinks about a lot. Even if we don't think about a cure, we think like, how can we make your honeymoon better or longer or more robust for you, just so that your diabetes was easier overall. But injected insulin, sort of as I alluded to a minute ago when I was talking to Dr. Hayek, is not the same as insulin that you make in your body. I mean, it's the same structurally and molecularly, at least similar enough, but it doesn't have the same route of transit. So insulin is supposed to go from your pancreas to your liver, and insulin is supposed to perform a couple of different functions. It's supposed to help you store sugars that you eat in your liver and in your muscle. And it's supposed to help your muscle not break down and to help your liver not make a whole bunch of sugar. Because when you're starving, your body basically makes its own sugar. So there's a lot of challenges in terms of insulin delivery. When we inject insulin into our muscles, it's not going by its normal route. And so we actually end up having to inject a lot more insulin than your body really needs in order to keep everything under control. And so that means we're a little bit more at risk of having a severe low. But also that if we undercalculate or miss the dose a little bit, we're at risk of being higher than we really need to be, and higher than we would be if the insulin was traveling on its normal route of delivery. So those are some of the challenges in terms of maintaining stability. And I guess the underlying message there is that it's not really always your fault when it's hard to maintain stability in your blood sugars. Part of it is just the way we're delivering insulin in the current times and how the insulin acts, and that perhaps there will be some pharmacologic improvements there. A few people have tried science in that area. We've had some research groups here at Vanderbilt and other places, and maybe we'll get some better answers to that will really help us.
Okay, great. Thank you so much. The next question, you touched on it a little bit in our first question, but can you talk a little bit more about how does T1D affect mental health?
Yeah, so I think there's a couple of layers there. I guess when I think about it a lot, I think mental health affects T1D a lot, as opposed to the other way around. Certainly when our sugars are off or things are really challenging living with T1D, that can impact our ability for maintaining our mental health. When our mental health goes sideways, that really affects our diabetes pretty directly. That's the easiest way I think about it, is that like you're a bucket, right? And your bucket is either full or it's not full. But the more that we've dumped into our bucket, the less we have room for the next thing. And so like a teen with diabetes, their bucket might be quite full with like sports and SAT scores and applying to college and doing their chores and other things. And they might have some anxiety sitting in that bucket too, that makes the bucket even a little bit more full. And then you try to dump some diabetes on top of it, and something's going to slosh out of the bucket. It might be their homework for tomorrow. It might be their diabetes right now. It might be something else that you didn't really expect. And that when we have mental health challenges, they're decreasing the amount of space we have in our bucket to deal with really everything else that we need to. And when you're dealing with diabetes, you have a lot of things you've got to integrate in order to be successful with that. And when your bucket's really full, you just often don't have room to dump in those more things. So getting help with that, counselors are often really impactful in this area. We have a behavioral health counselor specialist as part of our diabetes program at Vanderbilt, and she can help with families and conversations and some of those anxieties and stuff that are more about dynamics and communication. Sometimes people need additional treatment and management, including medical therapy for those things, and that's okay. That's not an embarrassment or a failure. That's just challenges that we live with, and often challenges that diabetes brings out. It doesn't always cause them, but because our bucket is so full, when diabetes tries to add on top of that, then those things come slashing out and they're visible for everyone to see.
Okay, great. We are getting questions from our attendees. So I'm gonna ask one, kind of segue a little more into research now, some research-based questions. So one of our attendees asked if you can comment on research being done on an artificial pancreas by a researcher at BU, Boston University in Boston.
I think they're asking about Ed Damiano's pancreas, who I think is still at BU, although sometimes it's hard to track these people as they move around the United States. And I see there's another question just about automated pumps in general. So I was sort of saying to Dr. Hayek a minute ago, I do think this is the thing that we are getting right now. Like this is the advance that's coming to us today. And, you know, advances come with challenges, right? They're not always easy to adapt, and they don't always perform exactly the way we'd hope. I think the Medtronic automated pump has been quite challenging in terms of needing a lot of calibration and a lot of babying for it to work. But at the same time, by having it out there and experiencing it, the universe is learning more about how to make that better and easier for us to use. But having a device that's monitoring blood sugars and adjusting insulin to those blood sugars does help people. And it's not perfect, but it is pretty good at avoiding lows. But certainly, I think one of the most threatening things to people with diabetes is going low overnight when no one is watching. So having a sensor can help prevent that. And having a device that stops pumping insulin if you begin to go low can also prevent that. So that's one of the things I worry about the most in college, when you're living out by yourself, that you not have every way to know that that's happening. And so these devices are quite good at that. They're still struggling a little bit to deal with food. The insulin's still a little bit slow relative to how normal insulin would have worked. Your secreted insulin from your healthy pancreas is quite fast, and the insulin that we inject is not as fast. So people can try to give insulin earlier. Certainly, we hope pharmaceutical companies and other people will continue to develop faster insulins that would help us with that as well. But in general, these devices are pumping people like to an A1C in the high 6s or low 7s. And with a little bit of additional work sort of on the part of the user, they can use it to really level out sugars and see some advances. I think people can achieve similar results by taking a lot of injections and wearing a sensor as well, so you don't have to wear a pump to take advantage of some of the new items, but having something constantly adjusting. If you can tolerate it, if your teen or child can tolerate wearing the item, if you yourself can tolerate that, that is definitely an advance, and it's going to continue advancing. So thinking about when you want to get on that boat, because it's going to keep improving when you want to learn to master those skills, I think is an important question to ask yourself about that. And then just to go back to the BU pump there, that's a pump that's supposed to be a dual chamber pump. It has glucagon and insulin. I think I'm still thinking about whether or not you need to have more than one hormone in your pump. I'm not ready to take a side on that exactly. People are still working on better glucagon preparations because most glucagon preps are dead within a few hours to a day. So they've been working to improve that so that they'll last for long enough to be in your pumps. They last through a whole pump change. You don't have to be changing your pump more often than necessary. That's like additional trouble no one needs. But the question is, for those kind of pumps, can we be more aggressive with the insulin, like on the gas pedal, if we have a brake like glucagon, or can we be aggressive with just the insulin by itself as far as turning it on and off, and how the changes in insulins and insulin kinetics relate to that? So the glucagon provides a really nice safety net, but in general, the pumps just with insulin by themselves have done a good job of avoiding lows. I think the question is just, can they be aggressive enough, like after meals, to prevent you from going high, or do they need the glucagon there sitting in the background so they can give you like a pretty good amount of insulin to go with your like turkey sandwich, and then put the glucagon on later to prevent you from going low from that dose? And is that better? And is it enough better to warrant the trouble of having to manage 2 chambers and maybe even 2 sites, and sort of having more than one thing being pumped at the same time? I guess I'd rather have like a device that's a sensor and an inset in the same thing, than rather than having 2 tubes and an inset and having to wear the sensor in a different place. I think most kids like just want one site. So that'd probably be the best advance for them currently.
Great. We have a couple of more questions directly from our attendees. One is there any research into insulin delivery in the, I don't know how to say this word, peritoneum?
So the peritoneum, so that's the space like basically inside your stomach cavity. So the idea is basically that stuff that goes in there gets absorbed into what's called your portal system, which is the system that leads directly to your liver. So that sort of brought up the question, like, would it be better to get our insulin sent directly to our liver, which is where it's supposed to go? And we've been working on some things like that here at Vanderbilt as well. We definitely are suspicious that would be better, that would be helpful, but how to do that is really a question. And sort of dumping the insulin directly into your peritoneal space, into your stomach cavity, might achieve that. I think we're still, at the stage of worrying about risks and benefits. So has it been done? Yes. Does it seem to deliver the insulin in the right place? Yes. Been done a little bit more in animal models than in people. I think that my main worry at the moment, though, is that we're talking about potentially really young people, or even people that are younger than me and Alberto, having to wear this or do this for a really long time. And can you keep replacing a device that's maybe inside of you, inside your peritoneal cavity over and over? And is that going to be safe over the long run? I can say I do worry a little bit too about having a whole bunch of units of insulin sitting right there ready to dump it into my peritoneal cavity, because certainly if it makes an error, I could be in really big trouble from that, or if it cracks or breaks, or I'm in a car wreck or something, along those lines. But I think this is sort of where research meets the clinic, where the clinical stuff's raising a question, and research is potentially bringing a solution. And maybe that solution's not what we want to do for people, but we want to learn from studying it and studying how it would be helpful to help us decide, like, should we push forward in that, and should we find some other way to replicate that idea? Hope that was helpful.
What about, do you have any information on FIASP, the insulin?
Yeah, so FIASP is a sort of a Novolog-like insulin with what's called an excipient. So it tries to get into your tissue faster by basically lubricating the delivery. I think it is a little bit faster overall, but people don't seem to really like it because it's a little bit more stingy. Like your Lantus is a little bit stingy, and FIASP for most people is even a little bit more stingy than that. And so the amount of speed versus discomfort has been an issue for a lot of the kids that have wanted to try it, but then have not kept up with it. I do think it's been approved recently to be used in a pump too, and so those are much smaller doses, so that might be a good place for it over time. We'll just kind of have to see, but it's still not super fast. It's like a little bit faster. So it's kind of, if you like it, it's probably a little bit faster and it can work for you, especially if it doesn't bother you on injections. But if it for you or your kid and it does bother you, I would say that the bother is probably not worth what I've seen as the relative gain.
Great. Is there any science indicating that type 1s have a smaller mass of islets or beta cells, and any indication that a too small mass would have to work too hard and burn out?
Yeah, that's a great question. We'll try to answer this in a couple ways. Can I share my screen? Do you think, is that all?
Yes.
I'm glad to do that here. Oh, I am. Wow, that's cool. I'm just going to take over the whole meeting. So I'll show you something really cool, and I'll also answer your question. Right? I'll show you something that I think is cool. Am I sharing?
Yes.
And you can see.
Yes.
So, his question was, or his or her question, I didn't see who it was from, is about beta cells and islets. So islets are about like 1% of your pancreas. So if they were small, like you might not even notice that. But we and some other groups have found actually your whole pancreas is smaller in type 1 diabetes. Those are some of my friends here, but here's just a picture, right? Here's a healthy control pancreas and a 10-year-old boy weighing 64 pounds. And you can see it's like nice and thick and fluffy. There's your stomach up here. He like ate something, his stomach's half full, just liver over here. And you can see nice, big, sort of fluffy pancreas. And here's a basically identical kid, 10-year-old male, 64 pounds with type 1 diabetes. And his pancreas is kind of thin and stringy. He also, had a nice snack beforehand. Otherwise looks pretty much the same. And we've done this in like 60 people or so. And you can see some data here where like healthy people have a pancreas volume. Here's what's called a pancreas volume index, where we scaled it to how heavy they are. Their pancreas is like twice as big as people without type 1 diabetes. And so we're really interested in that, because we've always thought that like type 1 diabetes is just about your beta cells, but beta cells are like 1% of your whole pancreas. So even if you had no beta cells, your pancreas would still be 99% as big as it was before. So why is your pancreas half the size? When does that happen? And can that be useful to us as we look for treatments and things as well? So as regard to that specific question, are beta cells stressed out, and is that contributing to their demise? Possibly. So your beta cell can make like 6,000 to 10,000 insulin molecules a second, right? So it's like this incredible factory that's just making stuff all the time. But if you've ever worked in a factory or making stuff, when you make stuff, you make a lot of waste, and you're making a complex chemical like insulin, you make a lot of byproducts and other things that are possibly toxic. And making an insulin molecule actually does create a lot of stressful byproducts that are very wasteful. And so if you're not very good at making insulin, say your beta cell is only 90% as efficient as somebody else, and it's trying to make all these insulin molecules, and it makes a lot of extra mistakes, that might be very harmful to its function. And people are wondering now, well, which came first? Is the beta cell kind of a screw up, and it's been messing stuff up all along, and the immune system kind of got activated because of all these sort of missteps in making insulin? Or did the immune system hurt it a little bit, and now it's really stressed out trying to catch up, and now the process is being accelerated because the remaining beta cells are having to work, slightly harder and are making more errors in synthesis? And then how do these things interact? What is the interface between beta cells and the immune system, and who's the chicken and who's the egg in terms of how does this response begin? So those are some really good and important questions. And then how do you capture that for therapy? Do we need early on therapy that does something friendly to the islets, that de-stresses them somehow? Do we need to do that later? Do we need to do that always? Who would benefit from that? How much beta cells do you need to have left to sort of warrant saving them and stuff? There's a lot of really great questions at that interface that we don't know the answer to yet, but a lot of groups actively thinking about this.
Great. We have a follow-up question to the insulin question before. So does the new super fast insulin justify the cost?
Well, this is even like a bigger question, like what should the cost of any insulin be, right? I mean, I think I'm, as a pediatric endocrinologist or an endocrinologist in general, I'm very much on the side that, you know, insulin is sort of a public health good, and no one can live without insulin. And so you either need to make it yourself or receive it. And so if we're, you know, talking about life and liberty and pursuing our own happiness, then if we can't afford our insulin, you can't get very far on any of the rest of those things. You know, there's sort of a secondary question there. When should a brand new item cost more than the item that it's replacing? And how do you sort of determine what the difference in cost should be? But I certainly think everyone should have access to a reasonable, good quality, accessible insulin that allows them to maintain their quality of life and sort of in the best way possible. Currently, my personal impressions are, like I alluded to about current like FIASP, is that it's probably not enough for me to, like, I'm not even on that. So it wasn't fast enough or enjoyable enough for me to want to replace my previous insulin with that. I find like I can take the insulin like 10 minutes earlier because I'm an adult and I can decide like how many carbs I'm going to eat before we dole them out of the bowl. And so I can give the insulin like slightly earlier and make up for the difference in time that way. So I would think, but for some other person, you know, the cost might be very justifiable because they get a much better outcome. And certainly there are individual differences. And this is another area for, you know, future research, like how do we predict who will respond best to what kinds of insulin at what times? Are there genetic markers that can help us predict insulin doses and really adjust things more in a more finely tuned way? But certainly at the fundamental level, no one should go without insulin therapy at the amount that they need and with the quality that they deserve.
Other than traditional treatment, insulin, diet, exercise, etc., is there a complementary treatment that is effective, such as supplements, antioxidants?
Yeah, so there's sort of two questions in there. So far, there haven't, people have been thinking about this for a really long time. So, you know, 40 years ago when I was a kid, my mom had a book on like various supplements that would be useful. So there's some, I cannot remember the title of this book right now. It was a very famous diet and nutrition book at the time. So I got a lot of vitamin C and like aloe vera supplements and things when I was a kid, but my diabetes didn't go away or anything. And so there's not really any great evidence that there's any supplements that change the course of diabetes. A few like vitamin D and stuff are, you know, basically innocuous and have been studied, but none have changed the course and the doses or schedule delivered. A second question is like, are there adjunctive like pharmacologic therapies? So the type 2 diabetes, there's a lot of treatment options for people with type 2 diabetes, inhibitors of a variety of different kinds, insulin sensitizers, other things. So can those be helpful for people with type 1 diabetes? And will those help lead to a better outcome? And so the adjunctive space for people with type 1 diabetes is a really interesting space that people are starting to try to think about. I think some of that's been a little bit slow because a lot of those things are not approved for children. And we often think about optimal management of diabetes in childhood, but you know, more than half of all people living with diabetes are adults. And we really need to turn our attention, at least in part, to the things that are going to affect them over their entire lifespan, and really, you know, be cognizant of those things and try to optimize management throughout life.
Any best practices on kids transitioning to adult endocrinologists when they turn 18?
Yeah, so that's a great question. Obviously, always a very big challenge in the life of each family with diabetes. Let's say, in general, my experience, we don't generally transition kids at 18. They're often seniors in high school. Excuse me, doing a lot of talking, and often going to go to college, and they're not necessarily going to be living in their college city for long term. So I usually see kids through college age. Obviously, your insurance and other factors may impact that, and then sort of the practice habits and the practice you're coming from. But I find like post-college, as they really move on to life, is a better time to transition. But transition is not an event. Transition is a process. So really, if you're thinking about transitioning at 18 or 20, you want to back that up and think about what is the process leading up to a successful transition, beginning years before that. All right, so they're going to need to, like, how do they call the doctor's office? How do they refill a prescription? How do they, you know, be mindful that they don't have any refills left? How do they make an appointment? And they can start doing these things when they're 15, 16, 17, and those are a lot of the factors you're trying to transition. Because when you move from the peds clinic to the adult clinic, there's usually a lot less hand-holding, overall and a lot more independent. So do they know their medical history? Do they know what's happened at their last diabetes screening visit? Do they know if they've had their thyroid checked in the last couple of years? What do they know about themselves? And starting to let them take some ownership and leadership in their visits is what really generally leads to a successful transition. Like transition, generally something, not something that the provider does to you, but something that you accomplish generally through the own growth of the family and their management of diabetes when it happens most successfully.
What is the time frame from exposure to suspected environmental trigger and type 1 diabetes symptoms?
That's a that question has a lot of components. I think the fundamental answer there is we don't know. So the question that I heard, and certainly type back in, I didn't get this quite right, is there a relationship between any candidate exposure, development of autoimmunity, and presentation with diabetes? So, we're trying to unpack a lot of this. So there's a study called TEDdy, the Environmental Determinants of Diabetes in Youth, that's been running for quite a long time now, trying to understand, are there triggers at all? And are there specific triggers that could be actionable that we could take some chance on changing or doing something about so that people didn't trigger to develop type 1 diabetes? And they, in the last couple of years, feel that maybe there are a few viral triggers, but the association of that with diabetes is still not incredibly strong. And it's certainly not one for one, like if you see this, then you will have diabetes, or if you got this, then you will have diabetes in the future. For a lot of these, I don't know if everybody watched The Price is Right when they were younger or still watch it today, but my favorite game on that show, and what I think is illustrative of a lot of research, is the Plinko board. So the Plinko board was this big giant board, has a lot of little dowels stuck into it, and you drop a disc in the top and you hope it lands in the $10,000 thing at the bottom, right? And so you're interacting with a lot of things over the course of your life. And one of them may be a bigger dowel or a bigger impact than another, but every time you get bumped to the right, you might get bumped back to the left again. So I think environmental determinants may play a role in sort of moving us one way or the other, but they're probably not an all or nothing kind of event. And we know from some other large population studies that generally for people that are on the road to developing type 1 diabetes, they might show their first immunologic marker by age 3, they might show a second immunological marker by age 9, but we do not have a very good way of discerning, once you've shown some immunologic markers, how fast is it before you get diabetes in the future? So, somebody, even in twin studies, the first twin might get diabetes at age 5, and the second twin at, age 9, or the first twin at age 10, and the second twin at age 37. And, those are twins. They live together for a long time. They have a lot of pretty similar exposures, and they end up with diabetes at very different times overall. And we don't really understand what those differences are. We would love to, so we could take advantage of them, because certainly 20 odd years of diabetes freedom would be really great if we could figure out a way to capture that. I also think when you think about environmental things a lot, every time you get sick or you have a challenge, that's really like a stress for your body. So a lot of times we see diabetes, say in the winter or after an illness, but that probably didn't cause diabetes. Probably what it did is make your insulin needs go up temporarily, and that revealed you to have diabetes. And if you hadn't gotten sick, that February, you might have shown up with diabetes in June, but because you got stressed out right then, it just revealed that you were already about to have diabetes. And then I like to be really careful with the questions about the environment, because I really think for parents, these questions are really challenging, because it relates to a lot of potential grief that, like, if only I'd avoided whatever, then my child wouldn't have diabetes. And I really don't think that there's a strength of evidence that there's any one thing or one event that caused your child to get diabetes that if only you'd avoided it, they wouldn't have it now. There's just really not a basis to believe that.
Thank you for saying that. The next topic is a big one, and we know that there are a lot of unknowns, and you don't have all of the answers, Dr. Moore. But I did want to pose it because you agreed to at least talk about it to some degree that you can. So there are two different questions related to COVID-19 and type 1. So I'll start with one, and we'll go into the second one. Is it true, or have you heard the research of those with type 1 having a higher death rate if they also have COVID-19 in hospitals, higher than those with type 2 and other general populations? And the reason being poor glucose monitoring or possibly something else. So is there any validity to that, and have you heard it? What are your thoughts?
Yeah, so I have heard it. So there's there's a few studies supporting that. There's also a handful of studies supporting less risk in people with type 1 diabetes. I think what the research says right now is that we don't know. Kids in general and people with diabetes under the age of 25 have not been, at least so far, overrepresented. But that certainly doesn't mean that they're safe. And certainly doesn't mean that anyone is safe from COVID. But I think we're still sort of working through the data and trying to really acquire more information about this so that we can counsel people to the best of our abilities. We've been doing some studies here trying to actually really call and identify people with diabetes with COVID and really understand their experience, like on a very personal level, to understand what their risk factors may have been. Because a lot of times in these larger studies, not all factors are captured, because a lot of times they're just pulled from the health record, which is just sort of as good as whatever information went in. And we've been really trying to get out there and verify some of this information so that we can really understand and counsel that. But right now we don't know. I think we are worried. Certainly diabetes broadly has appeared as a risk factor several times. And I certainly would be very worried if I had poorly controlled diabetes that you would almost certainly be at higher risk. I find it hard to imagine that that would not increase your risk. But we don't know yet for a person running around with pretty well controlled diabetes, otherwise healthy, that doesn't have any other risk factors that be the same as a person without diabetes in their community, how much more risk, if any, are they at? And this is really important for our community to understand, like, how we should make decisions going forward. But at present, there's not any great answers. There's a lot of anecdotes, a lot of data that's been sort of partially analyzed, but not really to a full and valid degree. So I think in the meantime, and I think it's possible that some of the data is all over the place because people with diabetes are very mindful. And we're very thoughtful about taking early action to keep ourselves safe. So how many people have had it? Have we done a good job of preventing our own exposures as a type 1 diabetes community? What happens in general to people with type 1 diabetes are open questions that we really need answers to.
We have a parent that submitted another question about COVID-19. This parent says, I have an 8-year-old that was just diagnosed with type 1 in November of 2019, so hasn't had it even for a year yet. How nervous should this parent be for her child to go back to school in the fall? What is your opinion as a pediatric endocrinologist?
So as what I'm thinking and counseling people on currently is that your child with well-controlled diabetes or doing the things that are expected for diabetes management is, as far as we know, at similar risk to the other children in their community. And if school is open and that school is doing reasonable things, there's a lot of different kinds of schools, a lot of different schools doing different things, that if you would choose to send your healthy child to school, that your child with type 1 diabetes is probably a healthy child at this point with good control, that they could attend school and be similarly safe to other children. At the same time, we know even healthy children, right? Most children are doing really well with COVID in general, as far as we know. But there are some children who've had these multi-system inflammatory disorder and have had really bad outcomes with effects on their heart, lung, brain, other places. Those aren't kids with diabetes. Those are just random kids that don't have any known risk factors. So there are landmines sort of in the COVID, return to school plan. And so I think, schools have to think about these things very broadly, and how do we keep the whole community safe? Because we really don't know your child with type 1 diabetes, this other child we don't even know has a risk factor. Any child could be at very significant risk for the illness. And so I think we are part of that community. We're part of those conversations. It's important for us to engage with those conversations and sort of determine together as a school unit, are we doing safe things relative to whatever the infection rate is in your community, relative to what other happenings are going on in that community that are keeping people safe or putting people at risk, and trying to understand that sort of holistically, not just from the perspective of caring for your child, but how are things operating overall to create a safe or unsafe environment.
Thank you. We have another question. As someone who is interested in performing diabetes research, what are the best ways, in your opinion, to overcome barriers to becoming involved at different career stages, undergrad versus graduate versus post?
Yeah, so certainly I think about this a lot. I've trained students in my laboratory at all kinds of different stages who come and spend various amounts of time with us. I think the most ambitious thing I ever had was a young woman who was in high school who wrote to us and wanted to come do research. She wasn't from here. It was really kind of striking, but she said she'd written like 50 something type 1 diabetes labs across the country and no one else would write her back, which is really pretty sad because, you know, certainly we need people that are highly motivated, but we did write her back, and she came and spent the summer with us, and she was really awesome, and that was a lot of fun. And then she's been around for the last couple of years because she ended up matriculating at Vanderbilt after that, maybe because she had a good experience or she had a lot of fun, I don't know. There are a lot of summer programs. So Vanderbilt runs a summer research program that you can apply to as a college student, and there are also other programs around the country at other universities that you can apply to do summer research. As an undergraduate, your research to make an impact on diabetes over the long run, you don't have to start doing diabetes research right away, although I know that's the most motivating. What you really want is somebody that cares about you and cares about your learning and your scientific development and will teach you things and give you opportunity, because then you can take those things and take them on to the next level and move your way towards doing the research that you're most interested and passionate about. Certainly pretty much any graduate program around the country. So after undergrad, doing a PhD degree is going to have diabetes research as part of what is there. Again, you should find the mentoring group that, you know, really clicks with you, because you can always bring new knowledge to diabetes, and diabetes, like the Diabetes Research Connection or JDRF or ADA, is always hungry to fund, you know, new perspectives on diabetes. Like somebody went and discovered something interesting in yeast or zebrafish or somewhere else about insulin secretion. There's some fish poison that's basically an insulin derivative that an animal uses to like kill its prey, and it's like a super fast insulin. So somebody studying that from a whole different perspective is going to bring something interesting to the diabetes community. So there's lots of ways to arrive there. So it's a lot about persistence and kind of showing up and really wanting to do, you know, whatever's available right there today, because learning those techniques and thinking strategies and stuff can lead you to your goal of impacting diabetes research.
And this is our last question because we're almost out of time. We didn't get to all of the questions. However, Dr. Moore, I will send them to you after this. And if you feel inclined to write a message or a response to the question, we can then send that out to all of our attendees today.
I can come back some other time.
Oh, great. Yes, we would love to have you back. So here's our last question. Dr. Moore, how did DRC impact your specific research?
Yeah, so I became a faculty member at Vanderbilt in about 2012. And so as a young faculty member, you're trying to get all your projects off the ground and really trying to begin to make the impact that we just sort of talked about, that you've been thinking about for a long time. So I'd been a graduate student and a medical student. I've been a fellow. I've been a postdoctoral trainee. I spent a lot of time training, some like 18 years after high school, doing various kinds of training. And so what you're really looking for at that time is opportunity. Like you got like lots of ideas, but you need resources. They cost a fair amount of money to ask any of these scientific questions. To answer really any of the questions that you guys have raised today is going to take your time and resources and other ways to make an impact. So DRC really started funding things. I don't know exactly when their first year was, but I was, I think, the third person. So around 2014, 15. And it was just like really unique opportunity that you could speak directly to individuals that were interested in funding diabetes research, to tell them about sort of what project you had on the table that you were interested in moving forward. And you could get pretty quick support to really help you move that forward. Rather than spending a long time writing back and forth with agencies, you could really talk to people and have them potentially invest in your research. And so they invested in me very early and supported a project looking at some immune markers and immune cellular functions that might regulate diabetes progression. We published that paper related to that research not that long ago. But what you really, you as a community really gave me was the opportunity to keep moving ideas forward and to train a student on those ideas. And those ideas led to more ideas. And so that really helped us. It was like kindling for the fire that is my laboratory. And it really helped us get things going quite early that otherwise we would still be trying to get off the ground. And that led to new ideas and new applications. And I think it's really formed a chain of events that's leading us to maybe even new therapies that we'd like to try in the clinic over the next 5 to 10 years, and new approaches that we'd really like to see brought to fruition. So your support has been really very important in helping us get the very young lab into a slightly less young lab.
Well, we are excited to have you back. You are correct. You are our third project that we funded in 2017. Thank you so much for sharing. I'm going to go ahead and bring Alberto back in so that he can ask or comment on anything, and Casey will close us in just a minute. Alberto, let me unmute.
So much, Dan. It was really nice. We put you on the spot a few times, but the next time we'll have the tough questions in immunology.
Oh, I definitely had some extra slides, you know, for immunology questions, so you guys missed out on those, but next time.
Okay.
Thank you so much. Casey, if you would like to go ahead and close us, that would be great.
Okay, yeah, thank you again, everyone, for joining, and we're so excited. I say Dr. Daniel Moore for being a part of this event and making the time for us. We know you're very busy, but we're all really excited to hear from you. So I just wanted to close with a couple things. You will be receiving an email if you're attending. If you didn't attend and you're watching this, we can also send you an email. You can follow up with me, go to our website, reach out to us. We'd love to have you stay connected. We have a sign up on that will be in that email and on our website for you to be able to receive our e-newsletter, which will have all of our future virtual events featured. So if you want to join us in the future, maybe you have topics you want to share, feel free to respond to that email. And yeah, we would love to have you join us. I also wanted to announce that we are officially going virtual with our 3rd annual Dance for Diabetes. We are so excited to be partnering with a local radio station. I will give you more details soon. We haven't gone public with all of them, but it is going to be in line with DRC's core value of valuing innovation. We are going to do a non-traditional virtual event. So it's going to be a lot of fun, dancing, and we can't wait to share it with you. So that's September 30th. That's a Wednesday, and that will be 6 p.m. Pacific Standard Time. But we will send save the dates also in our follow-up. Please get connected to our community so that you can see what we have going on. Thank you so much.
Thank you.